Great. Awesome. So hi everyone. Thanks for joining this virtual webinar series hosted by the team at 12 Apps. Thanks for those folks who can join in real time, as well as people who will be watching later on asynchronously on YouTube. So this is Multimodal Weekly. We've been meeting on a weekly basis every Friday over the past like 8-9 months or so. As the name suggests, you can probably guess we focus a lot on interesting research in multimodal AI and foundation models. Sometimes we have community members give talks around innovative application of multimodal AI in different verticals. Since with 12 Labs, we focus a bit more on video understanding. We also try to spotlight projects around like video AI that folks like to share from our community. And lastly, we also have Ethan talks around tutorials and guides, leveraging platform and APIs. And so in some of the recent session, we have folks both internally sharing how to build our API to speakers working at startups talking about like multimodal in vector database to researchers exploring the frontier topics ranging from like vision transformer, vision number to like text to video generation, right? So for today, we have two speakers that focus a bit more on the industry real-world application of computer vision and multimodal AI. So the first speaker is Andrew Ballester, currently the Chief Product Officer at EyePop.ai, and he will give a talk titled "Computer Vision for Non-Engineers." So yeah, Andy is part of our Discord community and share a little bit or like some of the links and resources around EyePop. So yeah, super excited to hear more details around the startup, the product debut, and I think you also was like the CTO co-part of GoFundMe, right? In a previous life, which is a pretty big company in the I guess in like fundraising space. So cool to hear some of the backstory about that as well. And then in the second half of the webinar, we'll have Rob Gonsalves, who currently an engineering fellow at Avid. He actually been, I think he spent like 34 years, right, at Avid. So all your career there. This talk will focus on, bringing generative AI to media production, specifically like semantic search, and see how it can be utilized for the workflow in producing, content. Avid is one of those like OG of video editing. So it's just, I think it's very interesting to hear more on like how they, as in big company incumbents can adopt Gen AI and multimodal AI as the world's moving around that dimension. Yeah, so for the audience, feel free to send your question on the Zoom chat, and I can pick it up and surface that to the speakers. And then after each speaker finish, I'm going to also like have a short Q&A as well. So with that, I stop sharing my screen and I let Andy, I guess that you can share your screen and go ahead with your presentation.
Excellent. One moment, let me pull up my presentation. All right, are you able to see my, it should say multimodal minds?
Yes, I'm seeing it right now.
All right, good to go. Well, thanks everybody. My name's Andy Ballester. I'm one of the co-founders for EyePop.ai. My role there is as the Chief Product Officer, but I've had roles between product and technology my entire career, including co-founding and CTOing GoFundMe. And so I'm really excited to talk to you all about what we see in the industry, and specifically in the computer vision industry. And so after I left the day-to-day at GoFundMe, I mentored quite a few startups here in San Diego, including a cohort of computer vision companies. And we saw 4 companies start fundamentally the same technological task 4 different ways, and have a lot of complexity and trouble going into it. And so we started to research why was that? And so I'm a product person, I'm a tech person, I love getting right to the demos. I'm going giving you this teaser here. We will get to the demo like very briefly, but I do think like some context around why we see this as a problem is a good lead up into getting into the product. And so here's what we found. Out there in the world, this is how web developers get to see their users' content. It's a black box. When a user uploads video or image to me, I don't know what's in there. There's not a lot of tools to help me understand what's in there beyond like humans going in there and taking a look. And so as this audience knows, when you use computer vision, you can start to understand human expressible features in images and videos, and we no longer have that black box. So we have that on one side, and that is what is happening in the web industry right now, taking images from users where we don't know what it is, and we put it in a bucket. It might be an S3 bucket or a CDN. We call it different things, but it's a bucket out there. On the other side, we see that there's a shortage of talented ML engineers. And depending on the place you look, it's a couple 100,000 in the world. We know that the demand for machine learning talent is going up. And we also know that startups are hard pressed to get the insights that computer vision and other AI would afford their product into their workflows, into their products to keep competitive with their with the other companies in their space. So we created EyePop.ai to build a self-service AI platform designed to make it easy for people. And so what we think about this, when we break down some of those terms, self-service AI to us means there's no sales call to get started. You have the documents you need. It's a place for creators that has a lot of accessibility built into it. We've made it easy. You'll see in the demo, it's a consumer level AI or UI, apologies. We've made the APIs that are associated with inference and managing your AI worker server accessible REST APIs. So I'm very familiar as a web developer and how to use those. And then for creators, there's no and low code options so that you can start to get to some insights before you even start coding. Lastly, we're specifically looking at the perception AI space. We're starting with computer vision, but there's other, as you'll see our workflow, there's other perception that fits very well into how we work that we would like to expand into. And I love working with multimodal and some of the vision aspects of multimodal, but I do think there is still going to continue to be a place for very purpose-built computer vision models as well as other perception AI models. All right, so I would like to show you a really quick example of how we think about building an API on EyePop. And so I'm going to stop sharing for one moment just to switch screens here. But what we're going to do in here is we are going to build an endpoint, and that should take about 30 seconds. We're going to point our code to that endpoint. We're going to get results from that inference, and we're just going to use a simple image upload today. And we're going to create rules around those results to do real work and to bifurcate flows in a fake startup product. And so here we go. Let's share my other screen. Had to stop presenting. There we go. There it is. Okay, perfect. Okay, so this is EyePop. And so when you create what we call a pop, you have three choices. To start with, a pop is a piece of computer vision functionality combined with an AI worker server on which to do inference. And it allows for easy connection for your code. We have three different modalities we think of that. in the center, the API pop, that's what we're going to be doing right now. That is the core of these other two pops. So we have one, an app pop. That is good for prototyping. We're going to see an example of that later in this presentation. But it's good to go out, get out there, use some low code to prototype some functionality and visualize what my model is doing. An API style pop, that's how I'm going to integrate it into my product. By creating one of these pops, we get an endpoint that we can do work with, and a report pop that allows me to point my computer vision model pipeline at a batch of images and get roll-up results about human expressible features within my batch. And so we're going to start by going into an API pop. And in here, we're going to call this Multimodal Minds. Here we go. This is provisioning an AI worker server on our cloud. And we'll talk about where the inference runs in a little bit. But you'll notice we don't talk about what models do you want to combine and some of those more technical aspects. We just talk about what use case do you want to solve here. And you're seeing I have a very cluttered background, so it's going to try to grab onto all kinds of different things. But we can change what it's looking for in here by selecting what kind of pipeline we would like to do. And so we've specialized in quite a few different person data points. We have some expert models within some common contexts that you might want to look at. And this we're adding to all the time. So if you check back with us in a month or two, you're going to see even more things in this list. For right now, for this API, we're going to use people and common objects. I'm going to continue, and you get a preview of some of the inference coming out of my webcam as you're making that decision. So now I have a pop UUID. This is how I identify my piece of code. And I can go ahead and create an API key. We see my pop on this dashboard. And I've already pre-set up a pop. And so to save everybody a little bit of time, we're just going to forge ahead. And so for this, I need to hide some of the Zoom controls here. Okay, perfect. So this is a piece of code that is running on my local machine. This is written in plain old JavaScript. We have a Node SDK, we have a React component, we have JavaScript, we have a Python SDK. Lots of different ways to consume your API pop. But I'm going to show you a quick screenshot. Here's the real code that we're doing here. This is what matters. Number one, I have to fetch information about my AI worker server. And so we do that with a function called popconfig. This takes my endpoint, which is standard for everybody, as well as my token that I've gotten through my API key. The next piece of code that we're going to run is when I upload a file into this interface, it's going to take that file, it's going to append it to form data, and it's going to do a very simple form post to my endpoint to get inference done. And so the way that would look like is in here. If I choose a photo, this is just a bio photo. We can see in here it found a cup and it found a person with various information. And so this is a well-structured JSON that just makes it really easy to start to determine what is in this thing. And so so this is fine. This is great for users, and they can do some cool things with that. But let's take it one step further, and let's start to visualize some of the things that I get out of this JSON. Let's take that same photo. We'll throw it through. We're getting our inference result. And this is using Canvas now to just visualize that in a little bit of a more easy way to just visually see what is it finding within the image, as well as let's just list out the things we've found so far. And so two things there. So let's imagine a world where I'm really interested in creating a space in my product where users can upload profile photos of themselves, and I want to community groom my user-generated content such that I know it's a person. I'm sure all have had experiences on different platforms where people upload things like a picture of their cat. And so when I upload this cat, we can start to put rules around what's in there. And now, if I'm looking to make a social network just with people, well, there's no, like nice JavaScript or browser library that just says, hey, there's a person in there. And so this is a way that I can start to get to this. On the right-hand side, what we've done is we have a simple rules-based system that you can create rules around this. Obviously, you can go and process the JSON yourself, and it's really not that hard to do. But we've tried to make it even a little bit more concise for folks. And so in here, you'll see rules like, if there's more than one person, well, that fails our test. We just want one person in this profile photo. If there's only one person, that's great. That's an accept. If there are no people, that's a fail. And then way at the bottom, I have a rule if there's cats in it. let's just call that out. And so when we look at this, did not find a person, so that's a failure. And we do have cats. And so now let's look at a more arbitrary thing. I'm sure we're all used to kind of some just junk that like people upload. This is being detected as a clock, but it's certainly not a person. And so right here we have no people, and so that would fail. And then if we go back to my bio, only one person, okay, this is accepted. And so using those rules, now in my product, I can create flows based on this inference that will allow me to send the user to, hey, maybe try again with a profile photo that shows your head, face, and torso, and those types of things. Great. All right. So quick demo on kind of how you would use the API in basically its simplest form. And now I'm going to do a quick reshare. Apologies. See, it makes this a little complicated. Okay. All right. And so we looked at that. So in general, our workflow is always there's unstructured business or customer data out there in the world in the form of media. You push it through the EyePop system and you get JSON data out to make actionable insights with your product. Now, one of the things I wanted to talk about is like, okay, so under the hood, what are we doing? This is a more sophisticated ML crowd. Definitely owe you some architecture. And so what we've created is a wrapper around models. And this wrapper fits around a variety of frameworks. It fits around our proprietary framework, PyTorch, TensorFlow, all the big hits that you would expect. And it makes them interchangeable Legos that allow those models to be connected together regardless of framework. And once they're connected together, they can pass insights through in a graph, and then we roll up all those insights into a structured standard JSON at the end. And so if you look at a type of pipeline we're going to be looking at in a little bit, you might want to find out a lot of information about people all at once. And so in here, you can see what one of our pipelines looks like. And so we're using a person detector at the top. That's our proprietary framework that's being pushed into a more standard re-ID framework so that we can get some tracing data in video and live feed. We're using person pose estimators along with a 3D landmark model. We're using a palm detection model with hand landmarks. We're using face detection to give you things like a face mesh. We're also taking that face and we're doing expression classification. Is the subject happy, neutral, angry? And so all of that happens is as part of one pipeline in EyePop. All right, I'd like to show now a demo around our prototype type of POP in this prototype, we're going to build a simple fitness repetition counter. And so we all do reps at the gym. In this one, we're going to do reps on bicep curls. Can we count how many that I do? Now, my home setup is there's a little tight spacing here. So we're going to do our best here and try to get me in frame. But we're going to go back into EyePop. And this is the last switch over, so that's good. Okay, and in this one, we're going to go over and jump into an app style pop, and we're going to call this reps multimodal minds. And in here, now this one's going to be a little bit more complicated because we're actually creating some sort of visualization in this one. And so to begin, we're going to start off just like the API pop. In this one, I'm going to choose person, but we're going to take some 2D body landmarks. And so as we continue through this flow, you'll see in real time, we're switching over the pipeline. And so not only does our wrapper wrap the combination of models that are working together, but it also can replace that pipeline of models that are in real time. And so you just saw it hot swap over to this. The default is person and common objects. Now, also in real time, I can take some of the visualization off. This is less magical. This is just pure JavaScript on the browser. In Python, we use other technologies for visualization. And so I'm going to leave the pose up because I think it's kind of fun to look at. And we're going to switch over here real quick to our docs library. And so we have quite a lot of starter code for different projects. We have a mocap project that you can mocap with 3D body points just from a webcam, or we've had people use YouTube videos that they wanted to mocap people off of. And so right here is what we're looking for. This is a piece of a rule set that describes bicep curls. And now we have other examples within our docs. You can see one of our developers kind of having some fun with some of the different rules here, jumping jacks, shoulder press, all that good stuff. So I'm going to take that, I'm going to copy that in, and I'm going to use something that we call our counter conditional. And in here, I can turn on this counter, and I'm going to cut and paste these rules in. These rules are being syntactically validated as I paste them in. So that is all happening kind of real time. And you can see that I have a valid rule set here because at the top right corner, I have my rules. Now this can be visualized many different ways. This is one way to visualize it. Now what these rules are saying is it's just like a state machine. It's looking for certain positions relative to other body landmarks. And so if we look through this, it's looking for the basic double arm bicep curl. If I just do one arm, that's not going to help. It needs both arms. And so as I come up, every time I'm coming up, that count you can see is changing. And so that's the ease at which we can create some really simple actions with conditionals. Now, we could also, with this, do other things like if I see these 4 states happen in a row, go do something else, like go ping a webhook, go do something that is an action on my product, roll up some analysis. But that's the general idea of how to use our app pop. And once it is created, so this is still just the create experience. Now I have a URL that for right now is private, but very soon we will allow you to share that out and get some feedback on your app pop and even host it elsewhere off of our site. And so let me stop and go back over here. All right, and that's it. So that's a quick look at what we've built over here at EyePop, and would love any questions that you might have.
Awesome. Thanks, Andy. I think really enjoyed your presentation. Very interactive. Super impressed with the the UX UI part of the product, and all the visualization, and make it very easy for like, I guess, non-technical folks to grasp the output, right? Audience, do you guys have any question to Andy? Feel free to just unmute, and or you can put in the chat.
I have a question. Very cool demo. You mentioned there were like these 4 companies that you encountered from this GoFundMe, and kind of that sounded like it was a motivation for this type of product. And can you tell more about what these companies, or maybe other companies that are actually using your product to, what do they achieve with your product?
Yeah. Yes. So we just launched in at the end of January. And so we've had a couple hundred developers come through, but behind the scenes before launch, we've been working with startups for their problems. Some of those problems you can start to solve with fairly generic object detection coupled with things like text and scene or simple segmentation. And then some problems you very much need to train a purpose-driven model off of a unique data set that no one else has and that startup has, right? And so we know training is going to be a very big portion of what we need to solve with folks. And so if you look at some of our case studies, and maybe I have a slide on this. Actually, I'll just talk through it. So some of our case studies, we have a medical logistics company. That company sends drivers out to pick up lab samples to bring them back and centralized to a more centralized distribution channel to get to a lab. And so some of the things they're looking for is, if I send my drivers out, did they pick up the right number of samples, and did they pick up the right samples? And those are things that we can determine with landmarks and points around what those samples look like. So simple object detection on samples, and then more complexity for a specialized use case there. We have a cargo logistics company that is looking at the condition of cargo that throughout the delivery lifecycle. And so at different points along the way, it gets photos taken of it, and we can check that, yes, that's the right cargo that was supposed to be there at the right time, but also the condition is good along the way, where we found the condition was good the last stop, but now it's now there's some dings or some other issues with that cargo. So we have a sense now, just using imagery, about where that happened in the process. We're working with a professor finding archaeological sites in satellite photos. And there's a very specialized kind of site archetype he's looking for. And so that's a really fun one, because he trained us in about 30 seconds about how to, like a human would look for that in a certain region of the world. And so now we're trying to figure out how to make that data accessible to lots of people studying that. So wide variety of different things that we can look for.
Yeah, here's what I understand.
Yeah, thanks for sharing that. Such diverse use cases on the product. I also really like the part where you can automatically generate the JSON file from the output. I think for web developers, I think that is a very useful input, right? So that can like build stuff on top of it. Any other question for Andy? Okay, sounds great. So I think that's sort of end of part one of the webinar. Andy, if you have any like follow-up resources, like CTA, for attendees to follow up, maybe try out your product, if you put on the chat, so folks can learn more. With that, Rob, do you want to start showing your screen?
Yeah, sure. And hey, thanks, Andy. That was awesome. Let's see. Can you guys see my screens? Okay.
Yep.
By the way, Andy, were they looking for like the Lost Ark or something? That sounded like a Indiana
No,
Jones.
I wish, right? Actually, my co-founder likes to joke. if we could find Bigfoot using computer
Oh,
vision,
that's cool.
that would be the holy grail.
That sounds awesome. Well, actually, the Grail would be the Holy Grail, but Bigfoot would be good too. Okay, so hi, I'm Rob Gonsalves. I am an engineering fellow at Avid. At Avid, we make film and video and audio editing products that are used for major motion pictures and TV shows. And that's with Media Composer, our video editor. And for music, we have Pro Tools that's used for a lot of songs, and it's also used in teleproduction for people who are mixing the sounds for movies and TV shows. But yeah, I'm going to be talking today about some research that we've been doing into using AI to create semantic indices that can be used for media management. So here's what I'm going to be talking about today, mostly about semantic media search, and I'll talk about various modes, text, images, audio, and video. I'll also talk about how this system can work with languages other than English. A lot of times the models are trained only on English, but it works pretty well to fine-tune them to work in other languages. And if we have time, I'll show you a cool trick with embedding math. So there will be a little bit of math in this one, and then conclusions and Q&A. So we'll just start right off. So if you work at a production company, you have lots of video, audio, text, graphics, all sorts of data. And the traditional way to manage your assets is to have people put tags in there to say, this is a frame of a person talking on a Zoom call or whatever. It's at night, indoors, interior, things like that. So these are like so-called loggers or taggers, and this has been going on for a long time. It's a very boring job. Now, you can use AI to extract some information and automatically tag media, and that's helpful, and that's a useful thing. But using a semantic index actually is a different way of looking at the problem. And in the end, it's actually much, much more powerful than tagging things, because a lot of times something doesn't fit the right category, and then you have to do other and things like that. And you have to manage a taxonomy and update and all that. Where if you use semantic indexing, all those issues go away. And so, yeah, so I'll walk you through that. So the original model that I heard about was from OpenAI. That's called CLIP, all caps, contrastive language image pre-training is what CLIP actually stands for. And some of the folks on the call might know about this stuff, so, or maybe not. I'll go through it relatively quickly. But the idea is to have two transformer models. One does text to encoding, and the other does image to encoding. Such that if the text matches the image, then if you look at the cosine similarity of the embeddings, they'll be aligned if the text matches the image. And these are models that were trained to do this. This particular model has 512 floating point numbers for the encoding size. It was trained in English only. But the cool thing is that you can use unstructured text. You don't have to type everything exactly right. If you get close to it, like it's a karate fight or something, it'll still do a pretty good job of matching it. That's the nice thing about that. And there's OpenAI's paper. And you could use this, and our customers use this to where they have a database of media or like asset library. And a background process could scan images and generate an embedding using like the CLIP image encoder. And then when you go to search for it in an asset management system, you type in youth hockey coach, and it creates a semantic embedding of the text, and then it does the cosine similarity math. A lot of databases now support vector search. Like you can use this in Elasticsearch and a bunch of other databases that can do fast semantic search through cosine similarity, and there's a little bit of the math for you there. One thing you notice, I'm showing you the raw scores here. It's interesting because I've been looking at this for a while. If you cross modalities like text and image, it never gets anywhere near 100%. In fact, the highest you'll ever see is about 40%. And that's because they're different modes. The text, as much as you can describe everything, there's still more information here probably than you can type. And so I have, in my experience, like a 40 is really, really good. Even the high 30s are good. If it's below 30 or certainly below 25, it's not very good. But if you do a text to text-to-text comparison, you can get 100%. If you do image-to-image comparison, you can get 100%. But when you cross modes like text to images, these are actually good numbers. A lot of people in UI like multiply by 3 or something and then clip it at 99 just because these are good matches, right? People don't like it. It's only 35% what's going on. So here's some results. This is from a little Google Colab that I ran, where I typed in a karate match, and you can see the results, and it tells you the time code offset as to where it is, or the swimmers shake hands, and you can see some numbers there like that. So it's very fast and it works well. Now, I mentioned there were 512 dimensions to the embeddings. So I was just curious as to what it looks like. So again, working in a Google Colab, I did dimensionality reduction just to see what the vectors are. Now, this is a latent space that the neural network decided on based on its training. So there's really no magic to the horizontal and vertical axes here. This is when you run the PCA dimensionality reduction. It's trying to give you the best look where you can see most of the data and things aren't hidden behind each other all lined up. And the t-SNE is another algorithm. It's interesting looking at the two of them. Oh, this is from Olympics footage where there were all different sports like swimming and karate and gymnastics over time. So this is over time, and I color-coded where the clusters are. So basically did scene detection in a way, right? You can see distinct clusters here. Although I like the t-SNE because it's super fine-grained. Right, this video is running at like 30 frames per second. So this frame to this frame, there's not much semantic difference. So they'll be in line like this. So if you were to look at the, what these embeddings look like for a particular clip, they kind of move around almost linearly, right? Because a lot of times there's no abrupt change unless somebody put something up, all of a sudden it's very different. Usually it's continuous. So I didn't really show the time dimension, but if you watch this over time, they kind of move around like that. And again, it's showing you could use this just to visualize like where are all your frames, but also you could use this as a basis of a scene detection algorithm by clustering like I did here. And now this is for audio. This is from a group called Lion, L-A-I-O-N, and they did basically the same thing that OpenAI did with CLIP, except for they did it with audio. And audio is variable length, so they basically look at the first 10 seconds. But if it's more than 10 seconds, then they look at chunks of it, and they also do one 10-second span, and that goes into their neural network. They use what's called like log-mel spectrogram. So instead of just giving it a raw wave files, there's some math to do a Fourier transform to get you into the frequency domain. So it's time versus frequency. And a lot of audio processing neural networks tend to work better if you do a little bit of feature extraction by finding the filtering. And you don't have to do that. The neural network could probably figure it all out, but it's just more work for the neural network. So it's pretty fast to run the Fourier transform, and then the system does a better job. But they did very similar to the training that OpenAI did. They got audio with text to describe the audio to end up in the same latent space. I found that there's some open source music files. This is from Trent Reznor, well, 9 Inch Nails with Teeth. He released the Pro Tools session file for that song, like the real song, and asked people to remix it. So I grabbed these files, like, the drum composite or the lead vocals. These are the names of the files. And then I typed in a description of what I heard. And with this graph, like yellow means it's a really good match. In fact, 43.5 is one of the highest numbers I'll show you here. It's aggressive male vocals, and then it's a Trent Reznor singing the song. That's a really good match. Where this is like the drum wave file. I just wrote driving drum pattern with heavy kick, and actually that is relatively low. But if you compare it to the other, so these are like non-matches, and on the diagonal is where there's a match. So this is the lowest of the matches. Or actually, this one is crackly backwards ambient noise. That's how I heard it. But it still did a pretty good job. It managed to find, if we did a search, these would be the top hits of the thing that it actually found. Yeah, so that's CLAP. And then there's from 12 Labs, Semantic video search, right? Because the first thing I showed you was just still images, just frames, but without any motion information. So using the 12 Labs system, I signed up. I got some video clips from the site called Pexels, which is a really cool site, by the way. They have open source video clips that are super high res. Although a note to James, I had to use FFmpeg to downsize it because these were like 4K files, and 12 Labs was like yelling at me that it was too high res. So I used FFmpeg and basically did quarter res, and then it was fine. And it didn't take too long for the system to index it. And there's more features in there than the search, but I'm interested in search, so that's what I did here. So here's my example. I typed in youth hockey player skating. You can enable the confidence scores. I suspect, James, that you guys multiply up that score a little bit. I'm guessing, I don't know, but just based on the still image one, 85 seems high, but you might be playing the same game that we play at Avid, is we give a little multiplier juice when you cross modalities, because the user, I mean, this is a really good hit, all right? They asked for youth hockey player skating, and that's a youth hockey player skating. So yeah, 85 in English is a good number. Actually, I would probably make it 90. But yeah, so here it's a similar thing. There's basically a database, and the videos came in, not just frames. And then when I do a search, it'll find it, and it does an excellent result. Let's see. Yeah, so I mentioned that the CLIP system was English only. But if you like Avid, we have users that speak a lot of different languages. So there's a great paper by Reimers and Gorovich where they basically did knowledge transfer. They fine-tuned the CLIP text encoder using the student master workflow. So the master is the English one, or the teacher, as I call it. So the teacher is the English one, and the German one is the student one. And they basically took text and fine-tuned it until it started to produce similar embeddings as if for the English ones that went into their fine-tuning data set. So they didn't touch the image side of the encoder because they didn't need to, because it's kind of like frozen. I mean, maybe there's some cultural differences of the images that you might want to touch the video encoder. But for what they did, they left the image encoder alone, and they just fine-tuned the text encoder to come up with similar embeddings. Oh, and it works in like 40 or 50 languages. And the coolest thing is you don't have to tell it the language. It automatically figures it out. So I show a demo here. This is what I showed earlier. Two swimmers shake hands, and we get some numbers like 35% match, which I told you is good. So here's the same thing in French. De nager sur la main. And it's a little bit lower if you compare. This is in descending order. But it pretty much found the same clips, or close to the same clips. But there's a slight drop in it. And then here's a language I don't know at all, which is Hindi. We'll have to trust Google Translate unless somebody knows Hindi here. I think that says two swimmers shake hands. And again, it's a little bit lower even. However, it still did a good job. It had like thousands of frames to choose from, and it did find two swimmers shake hands. Yeah, so that's using the text encoder from the Multilingual CLIP. Yeah, and I think we're doing okay time-wise, right? Yeah. So here's a fun little project. I found this paper called Embedding Arithmetic of Multimodal Queries from 2022. And so here, you might find an image that you're interested in. Like, I like the look of this restaurant here. But now there's some things I don't like about it. There's some things I want to subtract, but there's some things I want to add. So I have an embedding for this image that I found, but now I'm going to produce a positive prompt and a negative prompt. So I don't want to have a donutness. I'm going to subtract out the concept of donuts, but I'm going to add in hamburger. And there's also a scaling factor here that it sort of depends on how far away in the latent space are you looking in order to find a match. And then I just sort of fine-tuned it here. I don't show the number, but let's say this goes from like, 0.5 to 2, and this is about, a 1.7 or so, like that. So anyway, it's a scaling factor that says, look in this much range around the new location that we're looking for. And man, the system worked really, really well. Actually, this one gets the all-time high at 0.533 on the CLIP score. So yeah, it started with this image embedding, then it subtracted the embedding from donut and added in the embedding from hamburger according to a scaling factor. And then using that location, it then searched my data set to see if I could find images. So anyway, I think it's a little geeky, but I think this is a pretty cool feature because, you know, you might have a picture of a model and that's what you want, but maybe she's standing up and you want her sitting down. So you could do, you know, negative prompt standing up, positive prompt sitting down, and it'll probably, if you have pictures of it, it'll find that same model in a different pose. It's very similar to the way people use like Midjourney and other image generators, where there's both a positive prompt and a negative prompt. So I think that's just about it. Yeah. So here, I know I kind of went through it quickly, but there's a semantic search as a new way to find media without tagging everything. You can store the embeddings in a database. The databases are really good and really fast at finding things. Yeah, you can use unstructured text. And yeah, you could probably get better results than having all those people tag everything. And I also mentioned various media formats and languages, and as a bonus, I showed you how you could do a cool trick with embedding math. All right, so that's it for me, but I think we have some time for some questions if anybody has any questions.
Yeah, awesome. Andy, I saw you unmute. Do you have a question?
Oh yeah, I'd love to know more about how long it takes to encode images, especially when you're talking about like big videos.
Yeah, no, I got you. It's a good question. So the good news is it's really fast, and the reason for that is that it uses such tiny images. I think the standard clip is like 226 by 226 times RGB, so tiny, which is a slight problem because it's square. And so you could do like letterboxing, but you can also do kind of like what they were doing in CLAP. You could do more than one. You could do like 3 across and then one that's letterbox, and now you have 3. And it uses a variation of the vision transformer, VIT-B32, I think. So they basically fine-tuned the vision transformer, which is trying to do classification, but instead of doing a one hot encoder on the way out the door, they basically look at the second to last layer output, and that's effectively what the embedding is. It's it's like there's a series of dense layers, I think, in the VIT, and it's the output from the last dense at 512 floating point. So you resize your images down. In fact, when I was doing this for some customer data, you almost spend more time resizing than anything else. If you take a 4K image, that's big. And do you want to take everyone, or you want to take every second? And then you can do some tricks on the cosine similarity to only take them when things change. So you don't have to record everything. You could just record if there's a difference. So yeah, but you can run the CLIP image encoder or any of these other encoders I showed you on the CPU, and you're not going to be compute bound on the encoding. Oh, you can also batch it, right? So you can line up depending on how much. Let's say you're using a GPU, depending on how much VRAM you have, you can put 10,000 of these things into a batch, and then tell it to crunch through that VIT, and it's out in milliseconds. Again, there's way more overhead in getting the large image. You use like FFmpeg or whatever to size it down. That's 10 times slower than the encoding. But it is pretty slow. If you had a database with tens of thousands of clips, it would probably run overnight, I would say.
Okay.
Just to get you in the ballpark.
Yeah, that's perfect.
Awesome. So I saw two more hands. So Joseph, do you want to ask your question first?
Yeah. Thank you. And yeah, first of all, nice to meet someone that's building a video editor, because I'm also a company that builds a video editor. So
All right.
yeah, and so my question is, I tried to build something similar, and the biggest sort of the challenge that I ran into was how to calibrate between different modalities when you're not sharing the same exact embedding. For example, the clip and the clap, there are 2 different things, and if you
I know that's a real problem. Yeah, because actually clap they had nothing to do with CLIP. They just like trained their own. And so the embeddings from CLAP are not in the same latent space as the embeddings for CLIP, which is a problem. There are a few papers. I think there's a new one from Google and yet another one from University in Beijing, where people are trying to unify modalities. So it's an open area of research. For example, like there's some things that will say, oh, does this audio match this video, right? And so I know there's a paper like that that's out there now. Yeah, so where we are right now, and I should mention that text-to-text encodings are even different from that. And there's a bunch of them, and that's a very fast-moving space because it's used as part of large language models that want to look up grounding information using a semantic text search, the so-called RAG pattern, right? Retrieval augmented generation. So there's a ton of development right now on text encoding, which I didn't really show because I know the spirit of this is multimodal, so I didn't want to show a text-to-text demo. But yeah, this method works really well. If you had a transcript or a news story or lines from a show, and you want to say, oh, show me where they got into an argument, it'll do a really good job of finding people, yelling at each other, right? So the text encoding, however, again, the text encoding space is different from the image encoding space, which is different from the audio encoding space. I'm sure James will tell me that, is it the Merengue model, right? Your video encoding probably is not unified with CLIP, I'm guessing, right? So that probably has its own latent space, I think, for the 12 Labs video encoder, right? But yeah, right, I understand your point though, because what you basically have to do, assuming they're different, you would probably need just to run multiple queries or run a compound query, which you can do in Elasticsearch. Although personally, I would probably just do them one at a time, just for debugging purposes. In other words, like, hey, let's see if there's any video that matches this. Hey, let's see if there's any audio that matches this. Hey, let's see if there's any text that matches this. It's annoying, and sometimes the vector sizes are different too. But I think in 2024, that's where we're at right now.
Yeah, so the practical problem that I ran into, I actually tried 12 Labs API, and that was like the challenge that I ran into like a few months ago. I don't know about the newer model that you guys just released, but when I search for like a students playing basketball, there's like there's like some school related query. It actually gives me not only the video where like there's like a school logo on the wall, but also it also returns like the actual like some OCR based matching, I think, that are kind of reading from the text that shows up on the somewhere. And when you have these like two results coming from two different modalities, and you just search for like videos and like image and like other things, it's really hard to stitch them together, because unless you have like a section for different modalities, which I think in most cases you just want the best result, it's really hard to pick the one result that is the best, because the scales are different. Like the numbers that you were showing, the 0.4 is the best in terms of the image, and like 1 is best for the text, for example.
Right.
So that was like the biggest challenge that I ran into.
Yeah, no, I got you. And yeah, it's a real problem. There's a couple ways you can handle it. As good data scientists, you should have some test data, right? So before you deploy something for customers to use, humans can look at it. I guess you could ask a LLM, a multimodal LLM, to look at it. But either way, something should look at it and say, yes, this matches this, and this matches that. Like this description of the audio really, to a human's ears, matches that audio, and this picture or video clip really matches. And then you almost need to do like impedance matching, to use a double E term there, right? In other words, you'd have to run some tests and look at both the the absolute differences, the scores, as well as the standard deviation. And then you'd have to do a little math to normalize it, to say, okay, we know what's good, we know what's bad. We're going to run some tests. We're going to just write a very simple, you could do it in Excel, we're just going to do a quick regression to find out a good point to say this score meaning 1 or whatever you want it to be is because we normalize the scores knowing of the cross modalities of a particular system. And now at least you have like a fighting chance of being on the same playing field to give the user a user interface that has a equal set of scores, so they don't have to think about it too much.
Yeah. Yeah, thanks for that question, Yusuf, and also thanks for sharing some of the feedback on using the product. And we actually have a embedding API release probably like in the next 3-4 weeks that allows you to get direct, video embeddings from your data. So using that latest space, I think you can play around with a lot of the embedding math concept that Rob just mentioned, and that would definitely help with.
One more point on that, because we've seen this a lot with the retrieval. You could put a language model in line. In other words, with some prompt engineering and about the systems, you could say, like, don't just take the raw search term from the user, because they know what they want, right?
Mm-hmm.
And you can say, hey, language model, this person's looking for stuff. And by the way, this system is like this, and that system's like this. Hey, language model, tell me some good concrete prompts to use. Because I've noticed, for example, these systems are very literal. If, like, say I'm working on a new story about inflation in the US, all right, inflation drops 2%. If you take that text and encode it and search for images, it's going to look for somebody like deflating a basketball or something like that. It doesn't know like what are typical footage that's used for a story about inflation. Right. If they thought about it, they would say, oh, like angry customers filling their cars with gas, or maybe they're happy because the inflation's down. So they're like happy customers at the gas station. Now you've got concrete search terms that will do really well with these embedding systems. So it's almost like you could put a language model in line to handle that impedance matching. Again, it's kind of like an agent in the RAG system where the user asks for something, but before we do it, we're going to modify it just a little bit. And you could tell the user, like, okay, I'm looking for what I'm searching on these terms. You could be transparent about what it's actually doing. And then it might just do a better job. But that's just brainstorming, just based on the work that I've been doing with information retrieval.
Absolutely. Thanks for sharing that. We come close to like the top hour, and Gasper, you have your hand raised for like at least 10 minutes. So yeah, I'll let you ask the final question.
I just have 2 quick ones. I'm working in Avid right now on American Idol, so
Okay.
I'm coming from this question's coming from the user side. Is when do you think, Rob, we could utilize some of those workflows? And then on top of that, I'm one of those editors that also was an assistant editor. And
Mhm.
assistant editors, I always looked at myself as more of a data asset manager or media asset manager. That's kind of what the AE has become, especially in unscripted workflows.
Mhm.
And so when I look at this, the first thing I try to think of is like, well, how can I, let's say, perform my own metadata injection so these models could perform a little bit better
Mhm.
for every show I work on? Because it's
Oh,
like,
yeah.
okay, you found a basketball, that's great, but I don't care about a basketball. I care about X, Y, and Z.
Right.
So it's like, how can we get human beings
No, I
in
get you.
there,
Yep,
tweaking it?
sure. A couple thoughts. So to answer your first question, what I just showed you is just a research project. So we're, we'll be showing a demo of something like this at NAB. But if you're running a more recent version of Media Composer, you probably know about the way we redid the phrase find and script sync. I guess you're probably more interested in the phrase find, right? Where you can now, if you run with last year's version of Media Composer, you can now get a transcript out of the system and then do a search on dialogue. So that was like our first AI feature in Media Composer. So there'll be more AI features coming, but I'm sorry, I can't give you an exact date. I can just tell you that we're working on it. So there's a couple things that you could do. One way is with fine tuning. So if you know that this text will match, you expect it to match this image, and you have some examples, and you don't even need that many, for a particular object or subject. You probably only need 20 to 30 pairs of, like, when I type this, I want to get that. When I type this, I want to get that. And then the system could do like so-called low rank adapter or LoRa fine tuning, which would, based on the user's preferences, We can adjust the model to say, hey, now that we know where to find the good stuff or what to look for to find the good stuff, there's a way that we can fine tune the model to adapt to exactly what you're looking to do. So that's just one, just off the top of my head, that's one. There's other ways to do it, but that's probably the one that's most straightforward, because then the user interface is pretty simple. You just type what you're looking for and it'll come up with better results.
Great. I think that's a great way to conclude our webinar. Thanks both Rob and Andy for your presentation, diving deeper into your work and educating the audience with very interesting concepts. And I also appreciate all the attendees who asked great questions and engaged with our speakers. Yeah, so the recording of the session will be available on YouTube probably in like 2 weeks, and I'll be sure to share that with you whenever it's available. Yeah. Yeah, so if you have any question with the speaker, you can just follow up with them via email, and I'm sure they'd be happy to tackle any of those. Yeah, with that, appreciate you joining. Thanks for presenting, and hope you all had a great rest of your weekend.
All right,
Cheers.
thanks.